Oh, hello. Today we'll be talking about materials. We have been talking about load-bearing materials. We have been talking about this building skin, and we have been talking about finishes. And now we will be talking separately about materials and, as an extra, about appropriate form. If you want to know more about the material properties of the different families, then you will have to look at their weight. We have three families. One would be metallic, one would be mineral, and the third would be organic. So if we look at the density of these materials, metal would be rather heavy. You would measure this by tons per cubic meter or by kilograms to cubic decimeter. For water it would be around 1, and metals would be in the area of about 3 to 11. Minerals are in the 3 area. And organic materials are often as light that they can swim, so they are often below 1. We also have insulating materials. So these insulating materials are almost never metallic, mostly mineral or organic. Mineral, those are wools, and organic insulation materials you know as well, like for example sheep's wool. So we spoke about mineral materials being medium heavy. They are mostly brittle, and they resist well against compression and not so well against tension. Metallic materials are about the same in resistance to tension and compression. Organic materials are often well insulating. What are typical mineral materials? You have natural and artificial stone. Part of the artificial stone are ceramics as well. Then you have glass. All of these are mineral materials. In the metallic area you have cast iron. If you take some of the carbon out, you get steel. And then you have aluminum, copper, and copper-based materials as zinc, for example. So the natural materials are wood or wood-based, like glulam or particle board. What you could also have is bamboo or hemp or straw. In the plastic sector, we have 3 main categories. One would be thermoplastic. So this means that when you heat them, then they become malleable, and if they go back to the basic temperature, then they harden. And this is used in many products, like for example Tupperware or whatsoever. So those might be thermoplastic. Then you have elastoplastic, like rubber and rubber replacement, and then you have duroplastic. So duroplastic are resistant to thermal influence. So these would be resins and things like that, normally reinforced with glass fiber or carbon fiber or whatsoever. So in terms of properties, we have first of all physical, then we have mechanical and chemical. So the physical properties are basically things as mass, density, water absorption, swelling, evanescence, dilatation, heat capacity, which means the capability of storing heat transmittance as well. And then we have energy transmittance as well, G value. Then we have UV resistance, fire resistance. Mechanical properties are resistance to compression, tension. Then we have something rather particular, which is the breaking length. It's the idea of having an object turning around the Earth in space, and then by the turning of the Earth, this has a centrifugal force to it, so it stays in a certain distance and it's held by could be a cable, but metal is not resistance enough. And this is limited by the breaking length of materials. And breaking length of materials is about density and how long a rope or a cable of this material can be before it breaks. So something rather particular is the E modulus, and the higher the E modulus is, the more resistant the material is to deformation by physical impact, like, for example, tension or compression. And so if you take a balloon and then you inflate it, it has a very low E modulus. And if you take a plate of metal, the E modulus would be rather high. The capacity to do an elastic deformation as well. Steel has also a certain range where it will be possible to move it up and down, and it bends a little. Here we are in the elastic range. Then imagine this to be fixed to the table, and you push on it once again here with your hand or your foot, and then it might be permanently deformed. And so in this area here we have exceeded the limits of elasticity, and the deformation became plastic. So we have plastic deformation and elastic deformation, and if the air is out again, this balloon will be a little bit bigger. There's one part elastic deformation and one part plastic deformation in the balloon. A particular form of resistance is skid resistance. This you need in wet spaces, like for example swimming pools. And if you walk barefoot in a swimming pool, then you don't want to slide. So there are values for skid resistance. It's linked to humidity as well, and a little bit the worst case is walking with wet barefoot in a swimming pool. So the physical properties are rather important because they have a big influence on the general qualities of the material. If you take, for example, mass, if the material has a high mass, it could have glare or gloss, and it would normally be more resistant to compression, maybe more resistant to tension as well. This has a big influence on water absorption as well, on swelling and dwindling, on dilatation and thermal expansion, on heat transmittance. Normally, the higher the physical density of the material is, the better it conducts heat. Very important is fire resistance, and you will see that organic materials are less fire resistant. Natural and non-natural organic materials alike. Minerals are quite fire resistant. Metal attains a certain level where its resistance to tension mostly, or compression as well, dwindles, and it becomes subtle, so it starts to melt and it loses part of its mechanical properties. So that's very dangerous in terms of fire resistance as well, because the building might collapse. Heat capacity of materials is important to store heat during the daytime. So you heat up all these surfaces, then when it's night time, then this heat could be used to create a nice temperature on the inside of your space. This is due to the storage capacity of the surrounding materials. So brick would be quite okay for thermal storage, and insulation is not a very good storage material, and if you have a lot of insulating materials on the inside, you get a Barracks climate, which means the building adapts to the outside temperature very quickly. So this could be an advantage, it could be a disadvantage. If you want to, for example, to start your heating system, then you want quick reaction to the impact of the heating system. But if you want to use daytime heat at night, then you need materials with a high storage capacity. So third sector is chemical properties. This is mostly the reaction of materials to crystallizing salt. It's mostly stone and concrete. Then you have aging processes, which can be nice. Then we call it patina. And not so nice, then it would be corrosion or electrochemical corrosion as well. If two metals with a different capacity to resist electromechanical corrosion touch each other, and there might be a resistance to the impact of humidity, which could be pest on one side and fungus on the other. So one is animals and the other are plants. And a last important quality of materials are delivery sizes. For example, German bricks are 11.5 centimeters, 7.2 high and 24 long. And it's important to know in which dimension elements are delivered. This is also valid for roof tiles, for example. And these roof tiles might have a certain dimension, and you have to respect this dimension if you cover a roof with these roof tiles, so that you have no leftovers on the side. A sink could be one of those examples, and then you have to look in the catalog of the producer to know what the size of this sink is. And what could happen to you is that you want to have a door in your bathroom, and the door hits the sink because you haven't been taking into account the size of the door and the sink. So appropriate form, as you can see, we have different chair models here behind me. And all of these models are in a way classics. They have an appropriate form. You can see that metal can be used thinner as wood, for example, here. You can also see that the surfaces that you sit on are always organic on all of these chairs, because metal surfaces are not good for your butt.